Okay, so those are notations. Give me some word associations. Word associations with the derivative. Slope of the tangent line. We're talking about that today. Hey, you can't fool me once, not fool me twice. Slope of the tangent line. What else for derivative? Instantaneous rate of change. Okay, I'm going to use ROC for rate of change. Okay, anything else? What? Differentiation. That means take the derivative. Okay. Oh, you have one? Difference quotient, the limit of the difference quotient, right? We talked about the difference quotient. Awesome. I love it. Okay. All right. And also that's the same thing as the limit process. Okay. So today we're going to find equations of the tangent line and talk about when is something differentiable? Like when can I take the derivative? I do have this one. Okay, example 1A. Anybody have Dr. Bozak before? She gave me permission to use her name and her dog. So. Grab another one. Yeah, you just gotta have an extra one over there. Yep. Okay, turn to your notes. What page is that? 10, page 10. Yeah. Page 10 of the notes. Dr. Bozak finds that after introducing her dog Sunny, this is gonna be a big application problem, to a new brand of food, Sunny's weight begins to increase. After X weeks, I'm talking, we're not talking, okay? After X weeks on the new food, Sunny's weight in pounds is approximately given by W of X is that for 0 is less than X is less than 6 or equal to 6. Okay, that's my domain. Find the instantaneous rate of change of Sunny's weight after X weeks. What does this mean I have to find? Take the derivative. That means derivative. So we're going to use the limit process. For now, that's the only way we know how to take the derivative. So we're going to use the limit process. Let's see if we remember it. We can sing the song. F of X plus H minus F of X all over H as H drops to 0 is the formula to find the derivative, to find the slope at or to otherwise state instantaneous rate, right? So that's it. You got to know that. And let's plug in all of the values. So we did like the legwork the other day, and now we're just going to apply it. So here's our equation. And we're going to do X plus H here, plus 17. That's F of X plus H. Minus F of X is going to be, I'm going to write something and I'm going to ask you what I did wrong. What did I do wrong? Parentheses, yeah, right? It says 17. Oh. I did do something accidentally wrong. That is supposed to be 17. Thank you. Yeah, I did multiple things wrong. Okay, so that's plus 17. And then specifically, don't forget parentheses around that after that minus. People forget that and they ruin the whole problem, okay? So all over H as the limit of H approaches 0. Okay, let's simplify. Distribute. So root X plus H plus 17 minus root X minus root 17 all over H. I'm sorry, why did I make that root 17? It's minus 17. Minus root X minus 17. Okay, what cancels? 17. The 17s. And sadly, nothing else. So, oh, let's call this F prime of X. This stands for F prime of X. Or no, it's W prime. W prime. Do you see it's W of X? W prime of X. Whatever variables they give you, that's what you use. W prime. Okay. So W prime is the limit as h approaches 0 of root x plus h minus root x all over h. How do I simplify this? Because I still cannot plug in h equals 0.
Yeah,
Okay, so I can't take out a root x because I can't split up the root x plus h. So how else can I simplify? What's the word for the numerator? Yeah, parentheses, multiply it by the non-reciprocal, try again. Start with a C. Conjugate, forms the difference of squares. That's called rationalizing the numerator. So we're going to rationalize the numerator by multiplying by the conjugate, which forms the difference of squares. So I multiply by root x plus h, give me the sign, plus root x all over itself. Oh, that's sloppy. My bad, my bad. Root x plus h plus root x. Okay, now we get the limit as h approaches 0 of, okay, what does this a minus b times a plus b becomes a squared minus b squared, right? Difference of squares. So we want to make sure we square the first. That's root, what's root x plus h squared? X plus h minus root x squared is just x. Okay. That's why I make you memorize difference of squares right there. That nasty simplification there. Okay. And it's real easy, right? One step there. All over. Okay. We just write the whole denominator. Root x plus h plus root x. Okay. Then our x's cancel, right? Negative x, positive x. And to save some space, can we just erase those, right? And then we can cancel the a's, right? Okay. So boom, this is a 1 and that's a 1. So you get the limit as h approaches 0 of 1 over all this. Can I now plug in h equals 0? Yes. So this w prime of x is going to be 1 over root x plus 0 plus root x, which is 1 over root x plus root x. What does that equal? 1 over 2 root x. So I have my derivative. Okay. And now we're going to apply it. From here on, I'm going to be asking you some application interpretations. Before I get into this, I want you to write some things down. Try to squeeze this in wherever there's room. There's going to be a little more room in the your turn box. So I kind of wrote it. I'll show you where I wrote mine. I wrote it like sort of in this first example and over to the bottom of that your turn problem. So, couple things to write. Is this going to scroll over for me? I'm just going to do that. Okay. So the derivative, some notes. The units for a derivative, it is a rate of change. So it's going to be the unit for y, or f of x, in this case, w of x, right, which is your y, over the unit for x. The unit of y over the unit of x, right? So it's a rate like miles per hour or whatever. So, oops, it didn't, there we go. The units of a derivative, unit for y over the unit for x. The other thing you need to know is twofold. If f prime of x is positive, what do we know about the original function? F of x is, what do you think? If f prime of x is positive, is f of x increasing or decreasing? What do you think? positive, it is increasing. Okay? So if my function graphically, remember what like if I have something like this, right? My function looks like that. My derivative is the tangent line to all of this, right? The slope at that point. So if my derivative is positive, then I should be drawing this one here. If my derivative is positive, that means it's increasing. F of x is increasing, right? So this is f prime of x. If my derivative is decreasing, so if my derivative is negative, then f of x is decreasing. Do you see why? Because graphically, I'm taking that derivative negatively on the slope. Negative slope means the function is decreasing. Okay? The original function. So the derivative tells us about the original function. The first derivative tells us about the original function. All right, now let's go ahead and interpret this. So this part B is interpret the instantaneous rate of change, that's ROC, at x equals 4. So at x equals 4, what you need to do is we need to find the equation, or eventually we're going to find the equation of the tangent line. You need to find an x and a y and an m for y equals mx plus b. For this first part, interpreting the rate of change at x equals 4, you're going to plug it in. We know that w prime of x is 1 over 2 root x. So how do I find when x equals 4? I do. W prime of 4 is equal to 1 over 2 root 4. And that simplifies to 1/4, right? 2 times 2, 1 over 2 times 2, 1/4. So my question is, what does this mean? Well, first, let's assign units. According to what I just told you, what are the units of this derivative? 1/4 what? Take a look at the problem. It's your units of y over the unit of x. Yeah, Cassie. Pounds per week. Pounds per week. That's my rate, right? It's an instantaneous rate of change. So now I have to interpret this in context of the problem. So if Dr. Bozak asks me, hey, like, what's going to happen to Sunny's weight? You're going to say, no, this is a really important thing because I'm going to keep asking you this for several types of problems. So at 4 weeks, right? That's your X. At 4 weeks, Sunny's weight, whoops, is, what can I tell her? Is it increasing or decreasing? It's increasing because W prime is positive. That means W of X is increasing, okay? So I'm going to say that it's increasing at a rate of 1/4 pound per week, right? Another way I can say that is like all that stuff. At 4 weeks, Sunny's weight is increasing 1 pound every week. Or every 4 weeks. Every 4 weeks. Right? For one more week. So that's another way I can say it. Okay. Does that interpretation make sense? I'm gonna keep we're gonna keep going through that and practicing interpretations. So then we have to find the equation of the tangent line. That 17 got cut off and put to the next line. So find the equation to the graph at the point 4, 19. This is your x and y. Remember, a helpful formula is the slope intercept, or sorry, the point slope form. Point slope. Do you guys remember it? Y minus y sub 1 is equal to m times x minus x sub 1. Okay. So we're going to plug in, we need our x and y. And then we also need our slope. What is my slope? It's 1/4. How did you get that?
Rate of change.
The rate of change, the slope of the tangent is the derivative, right? That's why I told you, associate derivative with slope of the tangent.
Oh.
This is m, the slope of the tangent. If you don't have that written, write it. Okay? Slope of the tangent line. So we're going to plug those in. So x is 4, y is 19. Slope of the tangent line is the derivative at 4 at 1/4. So y minus 19 is equal to 1/4 times x minus 4. Okay. Sometimes I'll ask you to leave it in point slope. Let's go ahead and simplify it to a slope intercept form. So we just distribute our 1/4. Oops. 1/4 x minus 1. And then you add 19. Oh, absolutely. Thank you. Yeah, always let me know if I forget to do that. I'm doing two tech things here. Okay. And then we get y equals 1/4 x plus 18. And that is the equation of my tangent line. So if I say, if Dr. Bozak asks me, hey, Miss Alexander, like when I plug in, like if I want to know his weight after 10 weeks, what should I expect? I can plug it into this and be like, oh, well, that's what you can expect, right? All right. Would you guys like to try one or go on to the next content and come back to it? What do you think? Yep, no problem. That happens. Zoning out. What do you guys think? Do you have a preference? Practice or come back? Practice? Let's practice it. Practice, practice. Practice makes permanent. Notice practice not make perfect. Because if you practice wrong, you'll get it. Permanent. Whatever you practice makes it permanent. As a musician, if I practice something wrong, I have to practice it correctly 28 times, minimum 28 times to like undo the muscle memory. It's so wild. Similarly with yeah. But I was saying stay with us. Hard. I know. Do it. No senioritis. Oh, don't let me get you. Let's kick it back. Uh-oh. I'm gonna stay far away too. Stay far away from her. Anybody need any help? Pardon? So.
2x, that was way too easy.
On the derivative. So let's rate this one. And then the letters.
Find the derivative. Oh, that makes so much sense.
So. So then.
So what's the point?
First thing you define. So.
That's the way of plugging in that non-data. Have to plug X plus X for every X. Yeah.
65. Fairly fast.
How are you doing? Good? Okay, yeah. Sometimes you know how you doing? Any questions? Okay. Yeah.
Yeah.
This one they say.
So, right.
Just do it this one.
And the back plus H.
Oh, crap. I did something wrong.
First, yeah. Add-
Yeah, whereas mine's on eight because we were way too. So that's why that'll be good. Yeah, you looked in a separate part, but this is.
Uh-huh.
Yeah, pretty much.
Limit.
I'm saying I looked at negative one.
Oh, that's-
You actually- there's everything is slow.
Okay.
And then you.
So then you gotta plug it in. So five, and that's plus H. You got it.
She just wants to.
Yes.
Okay, now you didn't do the last part. That's what we were referring to.
Oh,
Just be two.
What's that? It's not right. There you go.
Plugging the funny X plus H, that means I did plug it in. Plug it in plus H.
Find the equation.
Okay. Now you put them to square it. Square it, square it. How are we doing right here? Any questions?
That's not. Get rid of it. That's what it.
Yeah. That's prime versus.
How would we put that in? For the derivatives of the equation, but anyway. It's just
So if we want you to find a tangent line of that at negative 1, 2. So what am I finding in the derivative? Isn't it okay?
Fine if I just did this.
That's right. You need to find it.
I mean, I'll get on tab.
Yeah. No, absolutely, yeah.
Is it F X prime? Just F.
F prime of X. Yeah. How are we doing? We good? So.
All right, let me go over it. Most of you got this part. And then, oops,
A negative 2 into your.
distribute that negative. Square double square. X squared plus 2xh plus h squared plus 1 minus x squared minus 1. The ones cancel. The x squareds cancel. You get limit as h approaches 0. 2xh plus h squared all over h. You can cancel out an h and you can now plug in 0. And your derivative is 2x. You should write f prime of x equals 2x or dy over dx is 2x. I should know that you label that is the derivative, okay? On to the part B. If I know f prime of x is 2x, what am I plugging in if I'm saying find it at negative 1, 2? I plug in negative 1 for x, right? X is negative 1, so you find f prime of negative 1. So this is, you want to find first the slope. The slope is the derivative, right? The slope of the tangent line is the derivative at that x value, at x equals 1, okay? So if that's what you missed, does that make sense? Plug it in. So f prime of negative 1 is negative 2. What does negative 2 represent then? The slope, it's m, okay? That's, the derivative is your slope. So y minus y1 equals m times x minus x1. Use your x and y minus 2 equals m negative 2. X minus a negative 1 becomes a plus. I'm going to trust that you know how to simplify this. It becomes negative 2x. Okay? All right, let's move on. What time do we end here today? 34. All right. Hey, nice try. All right. If we know h of 5 is negative 2, and the derivative of h is given by h prime, write the equation for the tangent of the graph of h at x equals 5. I love this Winnie the Pooh thing. I think it's because it's all the different ways you can write derivative. And it's just like him getting like, he becomes the king. It's just, he's more fancy every time. All right. So I know the original function, listen, the original function h of 5 is negative 2. The derivative is given, and I want the equation of the tangent line at x equals 5. What is the first thing I need to do? Plug in x to get what? The slope. The slope of the tangent is that derivative, right? So the slope is the derivative. The slope of the tangent is the derivative. So that's h prime of 5. You plug it in to this x cubed minus 2 over x. So 5 cubed minus 2 all over 5. Okay? You get h prime of 5 is, do you guys know 5 cubed? 125. So that's 125 minus 2 is 123 fifths. Let's just leave it like that. 123 fifths. So that is the slope of the tangent line. Then you just plug it in, right? Y minus y sub 1 equals m times x minus x sub 1. So what's my x comma y? My x is 5. My y is negative 2. Up here, do you see it? H of 5 is negative 2. That's your xy. So 5 negative 2. You plug that in. So y minus a negative 2 equals slope 123 fifths times x minus 5. Okay, so y plus 2 equals 123 fifths x minus, hey, that becomes 123. That's nice, right? 5s cancel. And then you subtract 2. That's not us. So it becomes minus 125. That is the equation for the tangent line. Okay? I am running out of time.
125. The minus.
It is.
It is, because I'm sorry, I chopped off that 2. I'm subtracting 2 more, right? So subtracting 2 both sides, so it's 125. Okay? All right. It's very similar from a graph. Let me just show you with a graph. F prime, if f of 2 is 7, write the equation at 2, 7. This is f prime. What is the slope at x equals 2? Ladies and gents, where do I need to look to find the slope of the tangent line this time? On the graph, because that's f prime. So at x equals 2, what's my y value? Looks like 3, right? 2, 3. So at x equals 2, it hits the function it hits the derivative at 3. So f prime of 2 is 3, right? So now I have, that's my slope. And now you just plug it in. Let's just keep it in point slope form. Y minus y1 equals, for time's sake, So y minus 7, yep, is equal to, the slope is 3 times x minus 2. And just leave it in that form, that's fine for now. Okay? So, one last thing. There's I get a little song here. I'm not singing it, but it's pretty groovy. Listen up. It'll teach you continuity. Asymptote. Can't differentiate, can't take the derivative. Okay, there's more, but I'll play that in tomorrow. But I want to go over this last thing, because it's really easy. Look at the graph. If there's a jump, a hole, a gap, cusp, vertical asymptote, or vertical tangent, it's not, you can't take the derivative there at that point. So on this part A function, at what x value is it non-differentiable? Where can I not take the derivative on this function in A? At x equals -2. It's not differentiable at -2. In part B, what the reasoning is, there's a sharp point. Okay, that's a cusp. Whoops, that's a cusp. Okay. B, what x value can I not take the derivative? It's not differentiable at x equals -3 because vertical asymptote. Okay. Quickly, we do have enough time. We have 2 minutes. I know the bell's going to ring at 33 for lunch bell, but make sure you finish this first. Go do the your turn. I just want us to say what each of these are, and then I'll let you go. I do have.
Which math will have this one on page reading into, you can do.
All right, for the first one, is it differentiable everywhere or no? For the first one, yes, there's no values. The second one, yeah, sharp point. Third one, no, this is good. Fourth one, yeah, the jump. Okay. All right. Hey, I think I have posted an optional worksheet. If you want to do that, I'm gonna post that.